Here's your Precal 9-105. It says, given the points, all these 3 points, calculate the area of the triangle formed by these points. So you're going to need to know this formula. So take a moment to write that down somewhere. I think you'd probably Google it also. Okay, so I'm going to grab the ordered pairs of the 3 points and put them in CAB. That's the first ordered pair, second ordered pair, and then you put ones, and then you find the determinant of the matrix. We don't know how to do that without a calculator, so I'll show you how to get your calculator out. And then you're going to take 1/2 of, well, plus or minus. So if it turns out negative, you're going to take the positive, and if it turns out positive, you're going to take the positive. So let's go ahead and set that up. So I actually drew it also. I put the ordered pairs in there, and then I just drew it on a graph. The shaded one is the triangle, because later it asks us to do a parallelogram, and so I wanted to see what that looks like. So here's how I get my calculator. I just go to my phone, and I search for a Desmos matrix calculator. Desmos matrix calculator. So that's how I do it, because it's a beta. If you go to desmos.com, or if you go to the regular Desmos, you might not be able to find, I don't know how to find the matrix calculator there, but it's a nice calculator. So I want a new matrix, and it's a 3x3, so I'm going to say I want 3 rows, 3 columns. I'm going to add the matrix in. I got to type the numbers in. I had 12, -1, 1. My dog is outside crying. -1, not, oops, 9, 1, -7, 12, 1. Okay, so that's my matrix. That's matrix A. So I would like to, what am I trying to do? Get the determinant of it, because that's what my little formula sheet told me to do. So I'm just going to press DET A. And it turns out that it is 21. And so then my formula tells me to take half of that number. So what is half of 21? Isn't it 10 and a half? Yeah, 10 and a half. So, right, because I took half of it. Now, you might notice that if this shaded part is the triangle, then I could, the way I made the parallelogram that goes with it is I made a line parallel to this one down here. So how did I do that? I figured out how far it went left and how far it went up. Like, I think it went left by 6 and up by 3. So I went left 6. Well, it looks a little weird, but up 3. And then I just connected my dots. So, but if you look at the picture, you'll see that really any triangle you can make a parallel. Like, you can take this triangle and this triangle are similar. So they're actually congruent. So I can just double this and get the parallelogram. So that's how I would do this problem. But I noticed in my magic book, I had this formula. I don't know if you can read that, but it says x1, y1, x2, y2. And I wanted to try that out and make sure it would work. And I plugged in, mistakenly, I plugged in some of these ordered pairs. And whoops, it did not work. And why didn't it work? Well, I went to the answer book to see why it didn't work, and they told me, oh, use 6, -3 and 13, 10 or something. And then I realized, because these up here, these are ordered pairs. To get vectors in component form, because this right here, they want vectors in component form. I'd have to see like how far left this goes. Just the same way that the same thing I had to do to be able to draw this is what I would have to do to be able to get the proper. I don't know if you can see that in pencil. I'd have to get the proper component form. So how would I do that? I could go, this thing went, like if I just go from here to here, like I just want to find the slope. I could go down and over, or I could go up and over. I just want the slope of this thing. So it's, I'm going to do it right. It went right by 6, and it went down by 3. Right, so I can put that in. Oh, oops, it went down by 3. So, and then let's see. If I wanted to get from here to here, I'd go right by pretty far. Let's see, what was this one? This was 12, and so right by 13, and down by, this was 9, and that's -1, and down by 10. So I could use these and put those in there, and I did. You find determinants go this times this, minus this times this, and then yeah, it gives me that difference right there is 21, but it's -21, but I want 21. So it's the easiest way to do it is just to double this to get the parallelogram. But if you wanted to understand why, if you looked in your answer book and you saw that they had some vectors, and I could have used different vectors. I could have like shown how this, like, I think they even use different vectors. But as long as the vectors are in component form, then that should work.